Welcome to Hari Chemistry. So, I am Dr. Hari Prasad. So, today's session we will discuss salt analysis, right? Practical chemistry. Actually, practical chemistry in three parts. One will be practical inorganic chemistry, practical organic chemistry, and practical physical chemistry, right? In the G advanced and mains and need point of view, regularly the questions are coming from the salt analysis topic. Okay, even Z advanced regularly, frequently, right? Both paper 1 and paper 2 regularly coming questions are 2 to 3 questions are asking, right? Direct questions only, factual questions are coming, right? But many of them are memory based only. So there is no intellectual question. Just read the notes properly and revise the notes and practice the equations thoroughly, then you will get the answers easily, right? Okay, now student, in this session we will discuss this salt analysis, only types of anions and cations, and the what type of reagents we are using for the identification of cations, and what type of anions are there and classified into different groups, and then followed by some only preliminary test data. The next session, student, we will discuss the identification of anions later, next session. But this session I will complete for the preliminary test, like I think action of heat, flame test, and borax bead test. Everything we will discuss easy way, right? Now student, so here our aim is to detect one cation and one anion in the given salt from the following ions, right? Okay, so in the intermediate, in class 12 CBSE board and practical, generally we have only single salt only, means it contain one cation and it contain one anion only. So we will do for the qualitative analysis for both anion and cation, right? Okay, so generally here this anions is called as a acidic radical and cations is called as a basic radical. Generally in the practical exam or while we are doing the qualitative analysis for this simple salt, usually we will do the test for anions, not for cations. So the reason is why, right? Why we are doing anions first, then next cations only. Why we are not doing cations first, then anions? The reason is simple, student, right? Whatever the reagents we are using for the cation analysis, it can destroy or interfere with anions reaction. So doing cations first can make anions identification is impossible, because this cation react with the whatever the reagents we are using, then this reagent cannot use for the identification of anion. That is very impossible. So that's why we are doing anions test first, then followed by the cation by using the different type of reagents, right? Okay, so now here generally this acidic radicals classified into three categories, student. One will be group 1 and group 2 and group 3, right? So what type of radicals are acidic radicals are placed in a group 1, student? Radicals which give a volatile product, right? Radicals which give volatile product with dilute acid, right? So these compounds are these anions are placed in a group 1 category, right? Okay, what type of anions are placed in a group 1, student? Carbonato, acetato, nitrito, sulfito, and thiosulfato, right? Simple: carbonate, acetate, nitrite, sulfite, thiosulfate, right? So these are placed in a group 1, right? Okay, group 2, student, radicals which give volatile products with concentrated acid, right? The radical which give volatile product with dilute acid, that is the group 1 radical, right? The radicals which give volatile products with concentrated acid, that is group 2, right? So in this case, student, what type of anions are present? Chloride, bromide, iodide, nitrate, and oxalato. So simple, remember, student, CBI NOx. Simple remember CBI NOx. So C for chloro, B for bromo, I for ido, N for nitrato, right? Nitrato or nitrate, not nitrite. This is nitrite, student. Nitrite comes under group 1. Nitrate comes under group 2, which give volatile product with concentrated acid. Next, group 3 radical, student. The radical which does not give volatile products, right? The radicals which does not give volatile product, right? So remember as, student, SP Balu. Remember as SP Balu is a folk singer. SP Balu is a folk singer, right? SP Balu is a folk singer, right? S for sulfate, P for phosphate, B for borate, F for fluoride, right? So these are the three types of anions we have, student. So we will discuss after this, the next session we will discuss identification of anions one by one, group 1, group 2, group 3 we will discuss, right? Okay. Now again, student, again we have three types of anion radical, that is acidic radical. One will be group 1, second will be group 2 and group 3. Group 1 will be what? Radicals which give volatile products with dilute acid, radicals which give volatile product with concentrated acid, radical which does not give volatile products, right? So here we have carbonato, acetato, nitrite, sulfide, sulfite, and one more is thiosulfate, right? So this second case you remember, simple trick, student, that is CBI NOx, and the third anion case you remember SP Balu is a folk singer. Next, then cations. These are basic radical, right? So in this basic radical, student, different groups are present, right? Here these cations are placed in different groups based on their different properties shows with the different type of reagents. So that's why each cations are placed in a different group, right? Okay. So group 1, student, reagent. So generally NEET point of view, simply examiners are making question with respect to the only type of reagent, right? For this particular manganese group, what type of reagent is used, right? Like calcium group, what type of reagent is used? Basic fundamental questions are asking, right? Okay. So this is a completely memory based only, just revise, right? Okay, right. Group 1, student, here the reagent we are adding dilute HCl. Group 1, student, the reagent we are adding dilute HCl, right? Right. So the cations which are present in the group 1, student, Ag plus, Hg plus and Pb plus 2, right? Ag plus, Hg plus and Pb plus 2, right? Okay. These Ag plus, Hg plus, Pb plus 2 reacted with dilute HCl and form AgCl, Hg2Cl2, PbCl2 as a white precipitate. Color related questions are asking. These first group anion form a white color precipitate with a dilute HCl. This point is very important, right? Okay. Now how to remember, student, right? First group reagent is HCl, student, HCl, and remember as Pa, right? So P for lead, A for silver, H for mercury. Remember as HCl Pa, PAH Pa. That is the useful trick, right? Okay. This cation will give only precipitate with a dilute acid. The remaining everything will be soluble only, right? Okay. Now again, student, we have a group second. So these group second basic radicals are classified into two different segments. One will be second group A and group 2B, right? Okay. So in this case, the reagent we are using dilute HCl plus hydrogen sulfide, right? So, and if this compound, right, the given compound does not dissolve in ammonium sulfide, this is the most important point, student, right? So here the compound does not dissolve in ammonium sulfate, then it is second A. If it is dissolved in ammonium sulfide, then it becomes what? Second B group, right? Okay. How we are classifying second A to second B, student? If the given sample, inorganic sample, is dissolved in ammonium sulfide, then it belongs to second A. Means it react with that, it will form a precipitate. If it is not, right, so if it is dissolved, means filtrate, saturated solution is formed. If the saturated solution is formed, then it will be second B group. Okay, now what type of cations are placed in the second A group, student? Copper, cadmium, mercury, lead, bismuth, right? Copper, cadmium, mercury and lead, bismuth, right? So these are very very important. Copper, mercury, student, cadmium, mercury belongs to same family only, right? 3d10 and 4d10, right? So copper beside group and lead and bismuth, you remember, lead is the fourth group element and bismuth is the fifth group element. These three all are D family only. Lead is the fourth group element and this bismuth is the fifth group element, right? Maximum cases, student, second A and second B, maximum are, remember, as fourth and fifth group elements are present. Only remember these three additionally. One will be copper plus 2, one will be cadmium plus 2, one will be Mg plus 2. The remaining all are fourth and fifth only. Tin, lead, arsenic, antimony, bismuth. That's it, student. Fourth and fifth group elements, you remember, that's it. Fourth group will be tin plus 2, tin plus 4 and Pb plus 2. Fifth group, you remember, arsenic, antimony, bismuth. As plus 3, As plus 5, Sb plus 3, Sb plus 5 and Bi plus 3, right? The remaining three are, right, copper, cadmium, mercury are belongs to what, student? D family only, right? Okay, easy to identify, student. Remember as trick as what? Fourth and fifth. Fourth is tin and lead, fifth is antimony, bismuth, and one more will be arsenic. These three are belongs to which group, student? Right, second A and second B family, right? Right. Now if this compound second A group elements cations react with dilute HCl, then followed by H2S hydrogen sulfide, gives a block PPT, right? Colored questions are asking, student, right? Copper, mercury, lead, everything will form block color precipitate only. Copper, mercury and lead, right? See, copper, mercury, lead will form block color, right? Block color. Cadmium will form yellow in color. Cadmium will form yellow in color. This is most important, student. PYQ G-Mains question, right? Bismuth will form brown color. Bismuth will form yellow color, brown colored, right? Okay. Second B group element, tin and tin plus 2, tin plus 4, yellow PPT. Tin plus 2 plus 4, yellow PPT, SSY, remember, right? As plus 3, As plus 5, dark yellow. SB, antimony, orange, right? Okay, yellow, dark yellow, orange. SSY, As, dy, right? Arsenic will be dark yellow, antimony will be orange PPT, right? Just revise it and practice, student, you will get the answer easily, right? Now group 3 cations, right? Group 3 radical is, student, the reagent is ammonium chloride plus ammonium hydroxide, right? Group cations, this is most important, student. One will be Fe plus 3, chromium plus 3 and aluminum plus 3, right? Group 3, all cations are having the plus 3 charge only, right? Okay, so remember as FAC, FAC, right? Okay, iron, aluminium, chromium, FAC, iron, aluminium, chromium. Okay, right? Color is very very important, student, right? One will be iron will form red PPT. Iron will form red PPT. Iron will form red PPT. Chromium will form green PPT, right? FRCG. Iron will form red and chromium will form green color. Aluminium will form a white color turbidity. This is easy. Aluminium hydroxides are generally, it can form a white turbidity only, right? Okay, so aluminium white turbidity, chromium green color, iron will be red PPT. Remember group cation as what? FAC, right? A FAC you remember, right? Next, group 4 cation student, nickel plus 2, cobalt plus 2, zinc plus 2, Mn plus 2. Reagent is student, remember the third group reagent, NH4Cl plus NH4OH. Additionally, we are adding what? H2S only, right? Okay, right. The trick to remember student, right? Jimco, you remember, Jimco. So, Jimco, zinc, manganese, nickel, cobalt, right? Jimco, you remember. Third group, you remember, FAC. Fourth group, you remember, Jimco. Zinc, manganese, nickel, cobalt. Every oxidation number will be +2 only, right? Okay. Colors are most important, student. Nickel and cobalt formed as a black color. Nickel, cobalt, nickel, sulfide will be present. Maximum cases black color, student. Here also above you can check it. Copper, mercury, lead is black color, and here cobalt, nickel sulfide also black color, right? Zinc will be dirty white. Zinc will be dirty white, and MnS will be manganese +2 will be pink or buff PPT. Pink or buff PPT it will form, right? Next, group 5 student. Group 5 remember as what? BSc, right? BSc, Bachelor of Science, right? B for barium, S for strontium, C for calcium, right? So same third group reagent student, add additionally ammonium carbonate, right? So cations are what? BSc, barium, strontium, calcium, right? Everything will form white precipitate only. Everything will form white precipitate only, right? Okay. So group 6 student, we don't have any reagent for this, right? These are called miscellaneous group we can write. Okay. So in this student, what type of ions are present? What type of cations are present? Ammonium ion, Mg+2, Na plus, and K plus, right? These compounds does not give PPT with any of the reagent. So that's why they are placed in a separate family, that is the group 6th family. Some cases we can call the group 0 family also, right? Okay. Group 6 cations are student ammonium, Mg+2, Na plus, and K plus, right? Next student, right? Then, so after separating the group anions and group cation, then how to do the process, right? Then how to identify it? Okay. First we will do the preliminary identification. We will do what, student? Preliminary identification, right? Okay. In this preliminary identification, take the sample, take the salt in a watch glass and observe. It is amorphous form or crystalline form. That is the physical state, right? Okay. The physical state you can write as, if it is just touch with the finger, just you check it. It is a crystalline form or amorphous form. Amorphous means nothing but, student, powder form only, right? Then by color, right? So by seeing the color, we can identify some type of cations also, right? Right. Pale green, right? So here I took some color of the compound also. If it is a pale green, so maybe iron salt will be present, right? It may be ferrous salt will be present, right? If it is a green color, right, a dark green color, maybe nickel salt are present. Whatever it is, you can take nickel nitrate, nickel sulfate, everything will be slightly green color only. If it is a pale green, iron salts, green nickel salts, blue color, copper salt. Remember, blue color is what? Copper salt. By seeing the sample also we can identify color. By seeing the color, by observing the color, we can predict, okay, what type of compound is, right? Next, if it is a bluish green, student, that is copper sulfate is possible, right? A dark blue color, that is the copper nitrate, and bluish green color, it is a copper sulfate, right? If it is a pink color, pale pink color, so usually pale pink color we are calling lilac, right? Okay. If it is a pink color, manganese, and if it is a pale pink also, manganese, right? Okay. So by observing these colors, we can predict the compound, what type of cation is present, we can predict easily, right? Okay. Pale green, iron salts, green color nickel salt, blue bluish green copper salt, pink color pale pink manganese salts, right? Okay, this is the color identification, right? Next we will move to the action of heat, right? Okay, how to do the action of heat, student? Simple, right? Take a small amount of salt in a test tube, right? Okay, take small amount of salt in a test tube and heated strongly, right? Use Bunsen burner and heat strong, right? Okay, right. So look at, student, here this is first one. So this is I have taken, this is a clean and dry test tube, add salt, right? Then heated by using a Bunsen flame, right? If any white sublimation is observed, it may be ammonium halide salt is present, right? Okay, this is the second test, right? Action of heat, right? Okay, so take the sample should be dry only, solid form only. Don't add water or any other solvent and don't dissolve. Take the normal given salt in a test tube, clean and dry test tube, and heat by using the Bunsen flame, right? Now look at, student, here questions are asking in the mains in 2016 also, right? Here this is the Bunsen flame, right? Here we have three regions, right? Region 1, this is the region 1, and this is called region 2, and this is called region 3, student, right? Okay, so in that 2016 paper, the question was asked where the maximum heat is present in that particular region, mentioned as a region 1, region 2, region 3, student. Usually this region 2 is hottest, right? So that will be the highest temperature will be present, student. The temperature will be around 1500 degrees temperature, right? So this particular hottest part of the flame, it is oxidizing flame, and below part is, student, this particular part, it is a region 1, right? So hottest flame will be region 2, so that above one will be region 3, right? Okay, here the temperature will be, student, region 1 temperature will be 300 degrees temperature. This flame we are calling as what? Reducing flame, right? Okay, region 1, region 2, region 3, right? So region 2 temperature will be what, student? 1500 degrees temperature. Region 1 temperature will be 300 degrees temperature. Region 2 is a oxidizing flame, region 1 is a reducing flame, right? Okay, now this is the action of it. If white sublimation is observed, maybe ammonium halide is present, right? Next, look at, student, right? Take the sample and strongly heating. If reddish brown colored vapors observed, just recognize that maybe nitrate salt may be present, because it will produce NO2 gas. It will produce, student, NO2 gas. That you can recognize, okay, nitrate is present, right? Similarly, student, right, take the compound in a clean and dry test tube and heat it, right? When, right, hot condition, it will give yellow color, and upon cooling it will give a white color, student, then which indicates zinc salts are present, we can identify, right? So on heat, on hot, yellowish color, on cooling it turns to be white, so then we can predict that is the zinc salts are present, right? Okay, so this is, student, action of heat, right? Next, so if so blue color salt becomes white on heating, right? So blue color compound on heating it becomes white, so then, student, that may be copper salt is possible. Blue color salt becomes white on heating, that may be copper salt is possible, right? Now any water droplets, right, like bubble water will be like soap lather, we can say, right? Like water droplet or soap lather is observed on the walls of the test tube, student, right? Maybe hydrated salts are present. This may be like iron sulfate or magnesium sulfate or zinc sulfate are possible, right? Some common names are there, student. White iron sulfate, FeSO4 7H2O we will call green vitriol. Zinc sulfate we are calling as a white vitriol, and MgSO4 we are calling as a Epsom salt, right? Okay, so this is, student, action of heat, right? Next, flame test. This is also most important, student. So mains point of view questions are asking here flame test also, right? Wavelength also I copied, and each and everything is there, student. Lilac, right? Lithium, student. Lithium color will be crimson red. Lithium color will be crimson red. Lithium color will be crimson red, right? Wavelength is 670 nanometer, right? Right. Sodium will be golden yellow. Sodium will be golden yellow. Wavelength is 589 nanometer, right? Potassium will be lilac, or we can call light purple, right? So rubidium will be rubidium. Rubidium, remember, as red violet. Cesium will be blue color. Cesium will be blue color. Wavelength I mentioned, student. Just practice and remember, this is points to remember only. Next, calcium will be brick red. Calcium will be brick red. Strontium will be crimson red. Student, lithium and strontium both are crimson red only. Calcium will be brick red. Copper will be blue green, and barium will be apple green. So here barium, apple green color will be what, student? Barium. So this flame test color, right? Just take the sample on a glass rod and heat on non-luminous flame, then it will give some color. Based on that color, we can predict what type of metals are present, we can identify easily, right? Okay, so flame test is, student, a small amount of the salt is taken in a watch glass and few drops of constant HCl added and made it into a paste using a glass rod. Yes, right. A small quantity of a paste is introduced into a non-luminous Bunsen flame using a platinum wire. Okay, so here non-luminescence means nothing but, student, that is the region 2. Blue flame of a Bunsen burner is called non-luminous Bunsen flame, right? So based on the color observed, just we can predict what type of metal is present, right? Crimson red, lithium, golden yellow, sodium, potassium, lilac, rubidium, red violet, cesium, blue, calcium, brick red, strontium, crimson red, copper, blue green, and barium is, student, apple green, right? So now notice, student, why cesium has the lowest wavelength, right? So the reason is cesium has lowest ionization enthalpy, right? So why? Because from the nucleus to valency shell distance increases, right? So the loosely bounded electrons is present in the valency shell. The energy required very less only. Usually energy is inversely proportional to wavelength only. So right, so that's why here the wavelength is less for cesium, right? Next, and one more point also we can write, student. Largest atomic size is the next point, and energy of emitted photons is high. So based on this parameter, student, wavelength of cesium will be less, right? Next, this is the last test for the preliminary test, student, borax bead test, right? Okay, now look at, student. So the picture I copied here. So this is the borax. This is the formula is Na4B2O7.10H2O. This is the borax white color powder, right? Use a platinum wire and make a loop, right? Okay, so take the borax and put into the flame, right? So after heating few minutes, then you will get a transparent bead. So that is called as a borax bead, right? So this borax bead is reacted with the metal, then it will give colors. Based on the colors, we can predict what type of metal is present, we can identify, right? So the test is very simple, student. Borax bead test is used for colored salts because borax reacts with the corresponding metal salts to form usually transition metals to form metal borates which exhibit their characteristic colors, right? The platinum wire is made into a loop at one end and borax powder is placed inside. The hottest part of the flame is used to heat the platinum wire that is holding the borax powder, right? So then borax swells and lose water and finally forms a transparent glassy bead, that is nothing but student sodium metaborate and boric anhydride, right? The formula will be NaBO2 plus B2O3. This is glassy bead, right? This is the transparent compound, that is a borax bead, or we can call it is a glassy bead, right? Okay, look at student, this is the borax on heating. So it lost water molecule, it will form Na2B4O7, then heating, then we will get sodium metaborate and boric anhydride. Now this boric anhydride react with metal oxide, so then it will form metal borates. It will form metal borates with a different characteristic color, right? Okay, so here student, oxidizing flame, reducing flame, already we discussed. Oxidizing flame will be region 2 and reducing flame will be region 1, right? So hot condition, cold condition, hot condition, cold condition, right? This is very very important student. Maximum mains examination point of view, the questions are coming from here. G advanced point of view, this particular segment there is no question, right? Okay, so chromium is present student, chromium yellow on hot condition, green color on cold condition. Just you can remember student, CRYG, all right. Oxidizing flame, hot condition only, right? Hot condition only yellow, the remaining cold condition, oxidizing flame, reducing flame, both the cases green. So remember as student, CRHYG, H for hot, Y for yellow, G for green, both all the reducing flame as well as oxidizing flame, cold condition. Next, manganese student, manganese violet, then no color, reducing flame, no color, manganese no color, only violet color on oxidizing flame, both hot condition and cold condition, right? Okay, next, iron student, iron yellowish brown on oxidizing flame, hot condition, and cold condition yellow, right? So brown will be disappear, yellow only appear, right? Yellowish brown, yellow, right? So remember student, green, right? So oxidizing flame, yellowish brown, yellow, reducing flame, hot and cold condition, green, right? Okay, right. Next, cobalt, all the cases blue color, remember as cobra, right? Cobalt, blue color, all oxidizing flame, reducing flame, right? Next, nickel student, nickel oxidizing flame, violet color, hot condition, and cold condition, reddish brown, right? So reducing flame, gray color, only gray color will form nickel only, there is no other metal compound is not showing, right? So gray color, right? Copper will be green blue, GB, so CGB, right? Copper, CUGB, copper, green blue, right? Reducing flame, no color, colorless. Manganese and copper, remember student, manganese and copper, reducing flame, no color, colorless, right? So remember student, cobra, cobalt will be blue, okay na, cobalt will be blue, right? So chromium, remember as student, CrHyG, right? So right, at least a few things you remember, then easy to answer the question in the examination point of view student. I hope so. This is the salt analysis completely theory and fact based only, right? More number of times revision for this particular entrance examination point of view. Thank you student. So please subscribe the channel, like and share to your friends Thank you.